Halo, Assalamualaikum warahmatullahi wabarakatuh. Today we will make a resume about antenna. Mrs. Marina Tiasa from Electrical Engineering 2024 Nusa Putra University. Yeah. Now we go to the antenna type. Yeah, dipole. Yeah, folded dipole, and then monopole, and then array. Yeah. Yagi Uda, parasitic array, and then pass array, and then loop, yeah, helical, turnstile, microstrip patch, and then this or parabola, yeah, and then ground plane and this cone, yeah. So you can resume again about the antenna, yeah. This is about the monopole antenna. 1/4 wavelength fed at one end, fed with unbalanced speed line with ground conductor connected to the earth ground. In practice, it usually requires an array of radials to develop a better ground plane. Marconi-T, yeah. And then when you set low frequency, the field should be vertically polarized, and antenna could be a tower. The tower is ground insulated and fed at point above ground with a gamma match jet increase upward. Yeah. Now this is the monopole antenna. Yeah, monopole. And then you can see this is a folded dipole. Yeah. Yeah. 300 ohm balance speed line. And then this is the arus, yeah, or the ampere, yeah, current, yeah. If the power is the same as the 1/2 wave dipole and current is reduced by half due to folding, then feed point coil voltage must be double, yeah. Power is the same with voltage, and then multiple by current is the same with 2 volt, and then 1/2, yeah. Resistance is the same with voltage divided by current, and resistance is 2 for voltage divided by 1/2 is the same with 4 volt divided by I. Current is the same with 4R. The result of twice the voltage and half the current is a feed point impedance that is 4 times that of a dipole. Yeah, now this is the radiation, yeah. Vertical monopole, yeah. This is the gain, yeah. The gain is like this, yeah. Yeah, 30 and then 150, yeah. And then monopole antenna. Now this is the voltage, this is the current, this is the voltage and current. Now it is lambda divided by 2, it's like this, and then lambda divided by 4 become like this: voltage, current, ground plane, and then image antenna, yeah. And then ground plane antenna, yeah, can use a counterpoint system of radial cut to 1/4 wavelength to develop ground plane elevated above earth. If used in a mobile application, the roof of the vehicle can serve as a ground plane. At low frequencies, a whip antenna can be used with a loading coil. Now this is the feed line, yeah. And then loop antenna typically is receiving antenna, yeah, uses an air core with radiation in the plane of the loop. A ferrite core loop stick is also used typically in AM amplitude modulation receiver. Radiation is in the same plane as the loop but broadside to the loop stick. Can also be used as a coil in the radio frequency tune circuit. Now this is the loop antenna, yeah. R1 transparency 200, and then this is ferrite core loop stick, yeah, and then 5/8 wavelength antenna application as a mobile or base station antenna. Omnidirectional response in horizontal plane. Advantage is realized in the concentration of low angle radiation in horizontal direction. Does not require as good a ground plane because feed point Z at 5/8 wavelength is higher, therefore lower current, and then Z is lowered to match 50 ohm feed line by matching section. And then helical antenna. Helix is spiral, yeah, spiral, yeah. An example, 1/4 wavelength dipole shortened into helix, rubber ducky for handheld transceiver, yeah. Typically several wavelengths long and used with a ground plane. Circumference is 1/2 wavelength. The turns are 1/4 wavelength apart. Application VHF satellite transmission cross polarization. Yeah. Now this is the helical antenna. Yeah. This is coaxial feed line. This is the maximum radiation, and this is blind reflector. Yeah. Helical antenna. And then this long wire antenna. Yeah. This is one wavelength antenna. Yeah. And then this two wavelength antenna, 3 wavelength, and then 4 wavelength, yeah. This is the gain, yeah. And then this cone antenna, yeah. Wideband 10/1 range, omnidirectional in horizontal plane. Vertically polarized, gain is similar to dipole. Jet approach 50 ohm. Application RX scanner antenna for VHF and OHF. Can also be used for TX, yeah. And then parasitic array, Yagi Uda. Array antenna can be used to increase directivity. Parasitic array does not require a direct connection to each element by a feed network. The parasite element accord the excitation from near field coupling by the driven element. A Yagi Uda antenna is a linear array of parallel dipole. The basic Yagi unit consists of 3 elements: driver or driven element, reflector, and then director. Yeah. Now this is developed on an fire radiation pattern. Optimum spacing for gain of reflector and driven element is 0.15 to 0.25 wavelength. Director to director spacing are 0.2 to 0.35 wavelength apart. Reflector length is typically 0.5 wavelength to or 1.05 that of the driven element. The driven element is calculated at resonance without the presence of parasitic element. The directors are usually 10 to 20% shorter than at resonance. Now this is the Yagi array, yeah. This is the director, this is driven element, and this is reflector. And then usually it stands of the one aluminum, yeah, here. Now this is Yagi Uda antenna. Gain is related to boom, yeah. Nah, this is the boom here. A number of director. Maximum directivity of 3 element Yagi is 9 dBi or 7 dBd. Addition of directors up to 5 or 6 provides significant increase in gain. Addition of more directors has much less impact on gain. Increasing n from 3 to 4 result in 1 dB increase. Adding a director to go from 9 to 10 presents an 0.2 dB gain improvement. Adding more reflector has minimal impact on gain, however, less impact on point Z and the backglow. This is radiation pattern for 8 element Yagi. Yeah. 3 beam width 3 dB and then relative gain, yeah, like this. Now maybe you can continue it yourself. Yeah, thank you for your time. Yeah, assalamualaikum warahmatullahi wabarakatuh, and please read or watch my